पेपर दे दिया बच्चों को? How many marks? 28 on 40. No, that was UT classes.
I got the 70 and 60.
It's on 20. You got how much you got?
17, 18 and 6.
6
There were 3 papers.
6 and 8.
You
12 and a half. 16 and a half and 15.
and you this girl, that girl.
Yeah. In the first one, I got 10. I only got my first one. So I got 11.
And you people, you
I got 12.
you didn't do it. You also didn't do it. For those who have not done the paper, take the paper and do it at home and give it up for correction. Maybe they'll give you a little less marks because of its late attempt. But the problem is you have to keep on practicing. That's all. What was the topic given to you all for the test? What was the topic given to you all for the test?
Water. No.
Atmospheric
Oh,
pollution.
sorry. Atmospheric pollution, practical work, and
Study of
gas cause. And the hydrogen.
Study of hydrogen.
Study of
Hydrogen.
Anyway, I've not done that. I have not done those chapters now. When I'm revising them, you should do better now. Because this is the second time I'm doing this entire portion. Is this clear?
Yes.
So now we've come to the new chapter. And the
Second.
new chapter, yeah, the second chapter. What's the second chapter? Chemical changes and reactions. Okay. Now, first of all,
I got 39 out of 40.
for food, very good, very good, very good. Okay. Now, first of all, what is meant by chemical change? And is a chemical change the same as a chemical reaction? Is a chemical change the same as a chemical reaction? Good.
No.
Don't say no and yes. It's not one word answer. You give me an explanation. Back up your answer with a substantial proof, reason. Come on. Is a chemical change the same as a chemical reaction? You said no. Why? You forgot. You
I think it is same with it because in both the cases we don't get original product by physical.
You? No idea. You?
I also think it's the same because the chemical properties of like the end products are different. So the end products like the
They are the
properties.
same. They are the same.
No, they're different in both the cases.
Why?
It's because they undergo some chemical change.
Change and reaction. I want to know because the meaning of these two words, change and reaction. Are they the same? If yes, tell me why. If no, tell me why.
I think they're the same because
I think no, we don't go by thinking. Yes, yes, no, no.
it is the same because the end product of both the reaction or the change, we get a new product which is like the physical and the chemical properties are different from the original products.
Yes, you in are they the same chemical change and chemical reaction? Is it the same?
I think all chemical change
Huh?
chemical reaction, but all chemical reaction are not chemical change.
No, I didn't understand a word of what you said, but you said
Yes.
something. It's the same. Why?
Because the substance goes a change to
Loudly. Because
the products undergo chemical change to form new products.
the products undergo a chemical change to new products.
New products.
The products.
New different products. The reactants react to give different products.
You, is it the same? You don't. You
I think it's the same.
think it's the same. Why?
Because both the end products are
That will be one example. Yeah, you, it's the same you say. You see, actually a chemical change and a chemical reaction. It's a very small line or line of demarcation between both of them. A chemical change can take place in a substance, okay, even as an individual. Okay, a change can take place as in the substance when the substance is alone. But a reaction always needs minimum two substances. Correct? New substances formed, yes, that part of it is correct. Absolutely correct. One part of it is correct. But a change and a reaction. For a reaction to take place, you need minimum two substances. For a change to take place, it can a single person, a single substance, a single chemical compound can bring about a change within itself. Okay? Factors bringing about the change in the reaction, factors bringing about the change in the substance will be the same. But as I said, like a line of demarcation is very, very, very fine. Okay? Here a single substance is sufficient, here minimum a double substance. Okay? So now, first of all, what is a chemical reaction? Let me tell you what is a chemical reaction. Now let's not bother about the chemical change. Let's just say, what is a chemical reaction?
Chemical reaction is one in which two or more reactants lead to a wider
Two or more products. Okay, what you said is a chemical reaction is wherein when two or more substances combine together to give you products which are two or more. Correct. Is she correct?
Not entirely.
Pardon me?
Not entirely.
What have you to add to that?
In some decomposition also. Like some chemicals break down to form more products.
And what did you say?
She said two or more add to form products. In some reactions, only one reactants breaks to form more products.
So when I say I, that is chemical change. That one that is breaking up, you could categorize it as a chemical change. But in a chemical reaction, minimum two.
Decomposition.
Pardon me?
That decomposition.
Yes, whatever it is. But a new what you said is a new substance is formed. Whether it's formed by just decomposition, whether by combination of another substance, okay? A new substance is formed, that's what you said. Do you have anything extra to add to that? So you're not paying attention. And that's disappointing. As it is, you are like a rare earth element coming in once in 10 classes, just once you'll attend. Why you're absent so often, I just don't know. What is preventing you from coming to class regularly, I just don't know. How your parents are tolerating this also, I don't know. And I don't want to know also. Okay? I don't even want to know. Because sometimes the excuses given by your parents are stronger than the excuses given to you. And that's when it becomes absolutely defeating. And I don't want to waste the parents are encouraging you. I have no problem. You're not my children. Not my children. They have paid their fees. That's their responsibility to see that you come to class. Okay. So, what did I say? What is the chemical reaction? A chemical reaction is a reaction when minimum two or more substances combine with each other. Okay? To give you two or more products or to give you brand new products. Whether they're two or more or only one, irrespective. Anything else besides that you want to add? Anything else you want to add to that general statement of a chemical reaction? Yeah.
There should be close contact.
No, those are conditions. But something else you want to add. It is reversible, there are reversible reactions. You can't say not reversible, it's reversible, it is reversible, there are reversible reactions, there are irreversible reactions. Yeah.
If new products have completely different properties, then
That's why you use the word new, no? That's why you use the word new, isn't it? So why do you repeat that word new? You don't need to elaborate. What else do you have to say?
It
Anything
requires
else?
more than two
Pardon
substances.
me?
It requires two or more substances.
That's what she said in the beginning. What else? What else? Yes?
The total mass of the reactants or the
That's the most important rule, that the mass of the products must be equal to the mass of the reactants. By what law? Laws of conservation of mass. What does the law of conservation of mass state?
The law of conservation of mass states that the total mass of the reactant should be equal to the total mass of the products given in a chemical reaction.
In a chemical reaction. So how do we ensure that the total mass of the product is equal to the total mass of the reactants? How do we ensure that?
By balancing.
By balancing the equation. When balancing the equation, where exactly do we add those numbers? In front of the compound, inside the compound, behind the compound, in front. Why? Why not in the compound?
Then it will change the chemical.
It will change the chemical composition of that particular compound. So you add only before it and not after. It's like you would say a cosmetic change. And a cosmetic change is always superficial. Okay? It's only superficial. In other words, that same compound wherein you have to add two molecules, in this particular reaction, you may have to add 5 molecules of that same substance in another reaction. So that is the, what you say, the quantity of that particular compound varies from chemical to chemical, from one reaction to another. Now, we come to conditions, or when do we say a chemical reaction can take place successfully? What are the conditions? There's one condition that we give. I'll answer you. One condition.
Close contact.
In close contact with each other. Okay? All right. Why do they have to be in close contact with each other? Yeah, okay.
So that the chemicals mix together and form something new.
Yeah,
So
you.
that all the reactants will come back and.
So they can interact with each other. Remember one thing, children. Chemistry is in your day-to-day lives. Okay? When there's a relationship between a boy and a girl, you say there's physics between them, there's mathematics between them, there's chemistry in between them. See the chemistry in between them. And when there's chemistry going on, will they sit far apart from each other? No. What do? They sit close to each other. What's the matter? He's sitting very close to you, you're sitting very close to him. Ah, is there something peculiar between both of you? My God, I'm getting scared. Okay, so you can't have long, distant relationships. To have a fruitful relationship, to have a beautiful reaction, so to shut up.
But she is laughing.
She's laughing,
Yeah.
and your mouth is wide open, and the sound is coming from where?
She was laughing for real.
Don't open your mouth, be man enough to shoulder your responsibilities. Don't point out your fingers at someone else. You are laughing, say yes. So, for a reaction to take place, for anything to react, you can't react from a distance. You've got to react in close contact with each other. Okay? So the reactants have to be very, very close to each other in order to interact with each other. Correct? Now, second one, and this is the first in close contact. Second reason. Second reason. Second reason,
Like supply of energy in the form.
that's too much. Very close to that. Immediately after being in close contact with each other. Second reaction. Second point, go stepwise. You, this girl, keep your books closed.
Mom, it's
What is the second? What's,
mom, is it because they're no, I don't know.
no, okay, you? Anyone? Anyone, yeah?
Mixing of the reactant.
That is in close contact with each other, no? Then, yeah,
Value catalyst.
that is too far away. I'm not saying it's wrong. It's too far, yeah. And very close. Immediately after that, after being in close contact with each other, what's the next point? No, they have to be always in the liquid state or solution state.
Or molten. It have to be in the aqueous solution.
In the, oh, one moment. What is it? What is it? Aqueous solution. Use the word aqueous solution. Correct. What's the aqueous
Mom, we had water.
water? And solution?
Solution is basically the mixing of.
Solution.
Yeah.
Huh?
We mix
What is the
it.
definition
Addition
of
of
a
solute and
solution?
solvent.
Solute and solvent. Okay. Am I okay? Am I right when I say it should be in the liquid state? Am I right when I say that the reactant should be
No.
in the solution state or liquid state? Which
No,
is
no.
correct?
Solution.
Now, why the liquid state is not correct? Yes, Ian. Why the word liquid state is not correct? Solution state is correct. Why?
Because the liquid state could be any metal, but then the solution is the combination of a solid and a solvent.
Yeah. Any other explanation?
Because the reaction that occur in other states of matter also, like in gases and solids also react.
We're talking about liquids, no? We're talking about gases and solids. Solids, no. Reactions will not take place in the presence of a solid. It has to be in the form of a solution. Why? Because children, remember one thing. If it's in the liquid state, in other words, it's in the molten state. That substance is just solid and become liquid. It's solid and become liquid. That's all. But when I say that it is in the liquid state, means that substance is the solute and is put into water, which is the solvent. And that water breaks up the compound into its individual constituents. And the individual constituents that keep on reacting. If I take sodium chloride, solid, and I just melt it, it's a liquid. It is molten. It is still sodium chloride attached to each other. Sodium and chloride in the liquid state. Correct? And if I take, say, potassium chloride or say copper chloride, also in the liquid state, and put them together, they will not react. But if I take sodium chloride solution, correct? That means sodium chloride dissolved in water and copper chloride dissolved in water. What has the water gone and done? Broken up sodium chloride into sodium and chlorine. Broken up. The bond has been broken by water. And the bond has been broken of copper chloride by water, copper and chlorine. And that sodium then will displace copper because it's free. Because it is free. And who has made it free? The breaking agent, water. Water is the breaking agent. Therefore, we have to say that the reactants have to always be in the solution state and not in the liquid state. Okay, use the word solution. Because water is the breaking agent. It has to break the ions. Okay, and then the ions are free to interact. Okay, so second one is solution state. Now comes the third conditions, the third condition for a reaction to take place. What do you need? You need heat. Heat. What type of reaction is that called? Another word for a reaction wherein you are adding heat. Endothermic, because you're adding heat. Any other word? From that word thermic, what type of reaction? Can you get a name from it? Huh? Exothermic. That's why you added, it can be exothermic and endothermic at the same time. Is it mouth shut! Is it endo or exo? Endothermic. So another word for endothermic, can you give me a name for that? One word to tell you that heat has been used. That is an endothermic reaction. One little word, beginning with T. Huh? Loudly! Thermal reaction.
Thermal decomposition.
Sir, all the time heat may not decompose. You idiots don't take words out of my mouth and wrong words, idiot. How many times do I have to emphasize on the word idiot? How many times? And then you say, I'm not laughing. She's laughing, he's laughing, everybody is pointing out to everybody, but all the fingers, one finger pointing, nine are pointing out, and that idiot can't see that. That idiot can't see that. Now, go this girl, go and put up a reaction on the board wherein it is a thermal reaction or an endothermic reaction. Come on the board. Quick! Okay, can you give me a thermal reaction? Quick, on the board. On the board. And write something sensible. Don't make an ass of yourself because you already know that you're an ass. Don't prove yourself to be wrong.
Marco.
Huh?
Marco.
Go and get it.
I guess I know what.
Huh?
Ma'am, you know what today? I sulfuric acid fell on my face.
Concentrated.
Dilute.
Even if it's dilute, it is hot.
No, it's fine. But like I was heating, I was making sulfur dioxide. So I used bent tube.
What are it? Ian, stop it. I'll crush the life out of you right here. Write down properly. And don't make the fool. So what happened then?
So like I was like making SO2 in that bent tube. So I like put the cork off for some time and I was heating it so it like
Yeah, because you get the test tube fix, they are going to move, take cook the
no,
test
I
tube.
was like moving continuously, but still it was like
No, the flame must have been very strong. Your flame must have been very strong.
how do we control that flame? We just
You,
use it.
there is
There is only the change of color of the flame, right?
no, you know that coal that is there,
Yeah.
you turn it, you're reducing it and allowing only limited amount of oxygen to enter. So it's becoming a reducing flame. It becomes a golden color flame. Golden color flame is not a hot flame. Blue color flame is very hot.
Our teacher said that we always need a blue flame.
You always need a blue flame because of the blackness that is there. But in your case, when she is doing the experiment, she can use a blue flame. But when you're doing the experiment for your precaution, you can use a low flame. Or if you're using a blue flame, reduce it and make that in the flame so big, make it that small. You can reduce it.
Ma'am, you know, in
K2,
mixed lime
K
water with
water plus, no. Actually, one moment, no, not at all. K2 plus, have you balanced the equation?
This is wrong. Like the product is wrong. You get
How you're getting K2O? The product only is wrong. Potassium, when you dissolve in water, you get potassium hydroxide. You don't get potassium oxide. That's wrong. You pull this equation, it's
ma'am,
wrong.
you know, in school today he mixed lime water with HCl and some other chemical. Now he was about to get kicked out of the lab because he didn't mix some chemical
Yeah,
and he was
but-
heating it. No! Yeah, you were,
Come,
ma'am, I
you
was
know, doesn't matter.
Ma'am,
Yeah, go.
is it a C? Yeah, sorry. Go ahead. Ma'am, I don't know the balancing.
What is the valency? What is the valency of sodium?
Sodium.
What's the valency of sodium?
1 plus.
And oxygen.
2 plus.
So then this equation, now you get it. Now you got it. Plain and simple. Plain and simple. Okay? Yeah. Next one. So we have got, so we finished up with what now?
but sodium carbonate
Close.
doesn't need.
Huh?
Right?
Yeah, it's a carbonates. Now see, it's difficult. It's very difficult here because you have to use it with HCl. You're supposed to use it with HCl, but it can be allowed.
Today
Now.
we created CO2, SO2 and
Why are you
HCl.
disturbing my class? Who the hell wants to know what you're doing in your school? Now, so what are the points for a chemical reaction? The first one is in close contact. Second point was what? What was the second point that I gave you for
Solution.
there should be the solution. Third point, heat.
Energy.
Next point, energy. Energy. What in what form? In what form there should be the energy? Light. Go and put light. If it is light, okay, give an example. What is it called? Right? If it is a light energy, if it's a light reaction, what is it called? What is a reaction with light
Okay.
photochemical? So go and put it on the board now. Photochemical, give an example for photochemical reaction. Okay, light. Third, next one, next point, 6 point. What is the next reaction, next condition for a reaction to take place? One is it heat, one is it light. Then Heat, light, and mouth shut.
Electricity.
Electricity. Do you know the thing, equation? Okay, go. Wait, let me finish the beginning. Heat, light, and electricity. So first of all, what are the 5 points? And so far, what 5 points have we done for the reaction to take place? What are the conditions for a chemical reaction?
12:1.
First, close contact. What is to be in close contact? Be very specific. The reactant, not substances. Don't use the word substances. Now you are aware of the fact that we're using reactant. The reactant should be in close contact. Next point, don't talk. They should be in the reactant should be in the solution state. Third point, heat. Fourth point,
Energy. Energy.
this is the fourth point that you're doing.
Yeah.
Okay, energy. What?
Photochemical electricity.
Energy in the form of
Light.
light.
Heat.
And then next one,
Heat.
Yeah, we
heat is
did
already
heat.
done.
Huh?
Heat is what we have done and we made a mistake. What is the next one? Heat is finished. Third is over. Then
Kinetic energy.
heat is over. Then
Sound energy.
where is it now?
Photosynthesis.
Energy. And shall I write electricity?
You should have put the light. I wanted light energy. Light. This is photo. I'm not saying this is wrong, but
Yeah, I understood.
Yeah.
Yeah.
correct. Sunlight. Yeah. Okay. Sunlight. Then next one,
I have to write what is electricity?
electricity.
Ethanol.
Electricity.
Light से आ जाता है.
So you have now, we have got now light. No, she's getting electricity. So 5 points are over. Which is the 6th point then after that? Huh? Catalyst. Okay? Catalyst. Now, no, sound, no.
Yes,
We are not
sound.
Only one.
we don't want to take that sound into consideration. Okay? You got that now? Electricity. Balance the equation. Balance the equation. Okay, yeah. 2 to the 4. Yeah, all right. Fine. Now, so we finish it. What's the next point is? Catalyst, isn't it? What are you doing?
Now I'm helping her.
For what?
She wanted the arrow.
H2 carry.
Why are you disturbing my class?
I'm helping her.
You want to get out? Or you want to take away my job from me? Come and do it. Come and sit here, I can go home. Come and sit here and I will go home. You're spoiling the discipline of my class. And I don't want to shout. How many times I'm telling you, behave yourself. This is a classroom. Maintain the discipline and the sanctity of your classroom. For you, everything is a joke. Next point. The last point was catalyst. Now, what is a catalyst? Yeah, what is a catalyst? Huh?
Catalyst is.
What is the point there? What's the matter there?
There should be dilutes of uric acid.
That you don't bother about it. This is okay. If we are conducting electrolysis of water, then it's a different story. This is just an example of electrical energy used for this equation. When we are actually conducting in the voltmeter, then you have to add and say acidulated water. Right now, this is okay. It's accepted. Now, what's the catalyst?
Catalyst is a substance that increases the rate of reaction by making part of the reaction.
Wrong. What is the catalyst?
A catalyst is a chemical that increases the rate of the reaction by not taking part.
Wrong. Anyone else?
Taking part.
Anyone yes?
Catalyst is a substance that alters the rate of reaction.
Alters the rate of the reaction. What is the meaning of alters?
So it can increase or
Increases or decreases. When will this get into your thick skulls?
I forgot that.
Thick head, whether it's forgotten or not, your head, your skull is thick. It's thick. It's not a question of forgetting. You're not so old, and I have not taught this to you centuries ago. Your head is full of sawdust. or muck, which is not penetrable. So what is a catalyst?
Catalyst is something that alters the rate of reaction that required.
Okay, so alters means what? You separate.
Alters mean it either increases or decreases.
So if it's increasing the rate of the reaction, what type of reaction is it called? What type of catalyst is it called? Is it called
Positive catalyst.
positive?
And
Or-
negative for decreasing.
Yeah, so it's called a accelerator. And it is called, and the one that retards is called a retardant. Okay, now write down an equation on the board, wherein you need a catalyst, whether it is a retardant or an accelerator. We only want to know that the presence of a catalyst in that reaction. Anyone knows of a reaction wherein you are using a catalyst? Anyone? Yeah, okay, on the board, go.
Can low temperature be considered as
Ah,
a catalyst? Can low temperature be considered as a catalyst?
What is it?
Can low temperature be considered as a catalyst?
No, it is conditional. It is not.
No.
KMNO4 is.
Not K104, you're using Fe,
And molybdenum.
Fe, and you're using molybdenum.
Post
Not 3,500 degrees. What is stupid? You put that off there. Sorry, it's only 200 degrees centigrade.
200.
200 to 250. That's so high. So write down the product now.
There was some pressure also.
Doesn't matter. You just write down this simple thing.
There was catalyst.
Okay, fine. Now, after the fine, last one, what is the last thing left? Last point left. Huh? Not temperature, you can heat, no. With heat, huh? Pressure. Again, for ammonia only, you can use this pressure. You can use 1 to 2 atmosphere, not more than that. Same, 1 to 2 atmosphere, same reaction you can use, okay, as an example. So you got that now? So what are the seven conditions required for a chemical reaction to take place? Yes. First point, 7 conditions for a reaction to take place. What's the first condition?
The first condition is that they need to be in close contact.
In close contact. Next one, separate.
Energy.
They have to be in their solution.
In the solution form. Then third one, heat. Fourth one, light. Then heat, light, and electricity. Then catalyst. Then pressure. Is this clear? All of you got that? Any difficulty? No. Okay. Now, open up the textbooks. How many of you have got Selena with you? And you people? You don't know what Selena? Okay.
Page number.
Page number 26. Now, give reasons. Silver nitrate solution is kept in colored bottles. Silver nitrate is kept in colored bottles, yeah?
So it doesn't react with light.
That's not a complete sentence. That's not a complete, what we say, explanation. Yeah?
Since silver nitrate dissolves in contact of sunlight, then
Doesn't dissolve,
decomposes.
decomposes into silver and and nitrogen, nitrate into silver and nitrate. Okay, it decomposes. Okay, it has to be kept in, yeah, it is to be kept into colored bottles. Okay, yeah. Molybdenum is used in the manufacture of ammonia. Molybdenum is used in the manufacture of ammonia. Yeah,
Like it acts as a promoter and increases the efficiency.
yeah. So you have to say that, you have to say very carefully here that when you take 1 volume of nitrogen and you take 3 volumes of hydrogen, that is 4 volumes altogether, you're getting only 2 volumes of ammonia. When the volume of the reactants is more than the produce, okay, all right, you have to use high temperature and high pressure. If you use high temperature, the ammonia is going to get decomposed. If you use high pressure, the entire, what you say, plant can burst. So we use low temperature and low pressure. This causes the reaction to go very, very slowly and the produce is very, very low. Hence, we use your Fe and molybdenum as a catalyst. Fe is a catalyst, molybdenum is a promoter to speed up the reaction and to get more yield. This is the complete answer to that question. Followed, since we are taking 1 volume of nitrogen and 3 volumes of hydrogen, that is 4 volumes of the reactants, and we're getting only 2 volumes of the product. Okay, we have to use high temperature to increase the product. We have to use high pressure to increase the product. This creates a big problem because high pressure, the plant can break. High temperature, ammonia can immediately decompose. Hence, therefore, we have to use controlled pressure, optimum temperature. Correct? Now, when you use optimum temperature and optimum pressure, the yield is very, very low. So we have to assist the reaction by using molybdenum, by using Fe as the catalyst and molybdenum as the promoter. Because only catalyst is not sufficient. You have to use a promoter also to assist the catalyst to get quick yield and a larger yield. Is this clear? Can anyone give me the answer to this question again? Why is it that molybdenum is used in the manufacture of ammonia? Ian,
As molybdenum is a promoter of the reaction.
huh?
Since the volume of nitrogen and hydrogen is 4 and the volume of ammonia is going to be 2. So if you use high pressure, the plant may break, and if you use high temperature, then the ammonia will decompose.
So what?
So you have to use the iron and molybdenum at the low temperature and low pressures.
Can you give me proper explanation?
Now because it's a promoter. No,
I said explanation. So can you give me a proper explanation of what I told you just now? Can you give me a proper explanation of what I explained to you just now? Why is molybdenum used in the manufacture of ammonia?
this is a promoter and the promoter accelerates the efficiency of the catalyst iron which is added to the
Oh, why did we have the catalyst in the first place?
we did but
Why? I know we did, but why?
to increase the rate of the reaction to make it happen.
You're not paying attention. You.
Since the volume of nitrogen and hydrogen is 4 and the produce and the products is 2, only 2, so the and if we use high temperature, the plant will break, and if we use high pressure, then
If you are at high temperature, ammonia will decompose.
and if we use high pressure, then the plant will break, and therefore we use low temperature and low pressure, and that is why the
But with
reaction.
low temperature and low pressure, the yield is very low and the reaction is very, very slow. Hence,
That is why
therefore,
we use
we use
molybdenum and
iron. We use iron as a catalyst and molybdenum as
promoter.
its promoter. Will you please repeat that? You're sleeping and I will explain this to you. Repeat that what I said just now. Why is it that we use molybdenum in the manufacture of ammonia? Can you repeat? No. What is wrong with you? You're sitting in front of me and speaking English and speaking so loudly. Can you understand what I'm explaining to you? Can you? Yes or no? Now what did you understand? Explain to me. What did you understand? What have you understood just now? What did you understand?
Since the volume of the reactants is 4 and the volume of the products is 2, so to increase the volume of the products, high temperature and high pressure and iron as a
High
catalyst
temperature and high pressure is required.
is required,
But
but it breaks the plant.
what to break the brand? Why are you not specific in chemistry? You can't write rubbish. Specifically, you have to mention chemistry, the system, and what you answer. Simple English, simple sentences I'm giving you. Who can give it to me? Yes.
So we use
You are not paying attention. Start from the very beginning.
The question is why we use molybdenum, right?
Yes, idiot.
Yeah, so it's, we use molybdenum because there are 4 volumes of the reactants and only 2 volumes of products. So we use if we use high pressure, then the plant will break, and if we use high temperature, nitrogen will decompose.
Not nitrogen.
So, oh, ammonia. Okay, so ammonia will decompose. So we use low temperature and low pressure, and iron as a catalyst and molybdenum as a fuel.
Rubbish. Absolute rubbish. I'm not repeating this for the last time. Whether you understand or not, I couldn't be bothered. Well, as I said, you people are thick-headed. And you've got sawdust or muck in your brains. Sawdust at least absorbs. What you have in your brain doesn't even absorb anything. In this equation, we have taken 1 volume of nitrogen and 3 volumes of hydrogen. That is 4 volumes of the reactants, and we get only 2 volumes of the products. With the result, we may have to use high temperature and high pressure to get the number of products equal to the number of reactants. But if we use high pressure, there's every chance of the plant breaking. If we use high temperature, ammonia is going to decompose. Hence, therefore, we have to use optimum temperature and optimum pressure. Now, when we use optimum temperature and optimum pressure, the yield is very less and the reaction proceeds very slowly. Hence, therefore, we use molybdenum as a catalyst. But we use Fe as a catalyst and molybdenum as the promoter to assist the efficiency of iron. Did you give me that answer? No. You asked me what is wrong. As if I'm at fault. Come on, repeat what I said just now.
Okay, so we have 4 volumes of the reactants and 2 volumes of the products formed. So hence, if we use high pressure to obtain the volume, like equal on both the sides, if we use high pressure and high temperature, the plant may break. And if we use optimum temperature, then the speed of the reaction will be really slow. So we use iron as a catalyst because iron will not increase the rate of the reaction of molybdenum. molybdenum as the
Molybdenum.
molybdenum as the promoter of it.
Okay. Now, okay. What do you observe, or how do you know that a chemical reaction has taken place? Now we know what are the conditions that bring about a chemical reaction. The chemical reaction, and we have taken all those conditions, 7 conditions. Now, how do you know that a chemical reaction has taken place? Yeah,
New substance is formed.
a new substance is formed. Okay, next.
Ma'am, the color of the new substance form might be different from the products.
Correct. Color
The state.
change.
The state of the product.
Yeah, it could be state of the product means what?
Like if the reactant is liquid, for the product can be gas.
Gas. Okay. Then
Like formation of a precipitate.
formation of a precipitate. Then
Effervescence.
effervescence also is there. Means gas. Gas is given effervescence. What else? What else?
Heat is
Heat is liberated. Heat is liberated. Heat is evolved. Okay. So
Evolution of smell and
evolution of
smell, odor.
that is with the gas. With the gas. So color, odorless. We can say a color and odor. Okay, is evolved. So what? How do we know that a chemical reaction is taking place? First of all, a brand new substance is formed. Immediately when we touch the apparatus, heat, we get the effective heat, so heat is evolved, okay? Then there could be a precipitate, then there could be a gas evolved, there is a change of state. If you have used solid, then the products may be liquid or in the form of a gas, okay? So these are the various conditions, okay? State, change of state, change of color, evolution of a gas, formation of a precipitate. Okay, these are the different reasons when that are helping us to realize that a chemical reaction has taken place. So go and write on an equation wherein the gas is evolved. Gas is evolved. Yeah. Okay, fine. Another one. Okay, change in the color.
change in color.
Change in color. You put blue under copper sulfate, not under Fe. Fe is not blue. Fe is blackish in color. Precipitate is formed. Precipitate is formed. Suppose I say HNO3 AgCl plus HNO3 AgCl. Okay. Suppose I say light is given out. How would you give me an
Light is
example?
given.
Light is formed. A bright
Emitted.
flame. Okay, let us see. Come on, let us see what he's doing. Light. Hurry. A big flame, bright flame.
Sodium plus water. Sodium plus
That's
water.
heat.
But there is a flame.
Why again you opening your mouth? You think you're the only child in the classroom, or what is happening? Control your mouth. You are suffering from a diarrhea of words and a constipation of ideas. Understand the meaning of that sentence. Yes.
Symbol for light. Symbol for light.
Nothing, just like that. MgO, not MgO2. It's MgO. MgO, idiot, not MgO2. I'm telling you that you're not paying attention.
Balance it.
And a balance equation.
It is MgO, no MgCl.
MG for
Go. All right. Write down the equation on the board. Calcium carbonate reacting with HCl. About the board. Calcium carbonate reacting with HCl.
And can we give like nuclear, like in uranium fission? Can you give an example that is it is like a could produce this plant?
Yes, you can. You can. Enough of space, come on. Calcium carbonate on heating with HCl. What do you get?
And do we have to read it like
Huh?
for the reaction to occur? Do we have to read it
Which one?
like this
Calcium carbonate with HCl. See what happens is HCl, if it is
Do we have to
hot,
read it?
if it is warm, even if it's at room temperature, you will get it. Because carbonate is getting warm very hot. Very-
This one.
Just give it a pen, give the pen to him. Calcium carbonate and HCl. So what are you going to get?
Chlorine carbonate. Plus
Chlorine carbonate, two non-metals, idiot. Idiot. Ravish, go and do it. Come on, Shwen. Yeah, you did. Go.
Idiot. Idiot. We just want to work this.
Do you know?
I know.
Give it to him. Give that idiot the pen. This is what happens when you stay absent in your class, in the class. This is what happens.
Mama, please.
All wrong.
No.
Is she correct?
No.
Is she correct? Then correct it. Go and correct her. You don't know. Is she correct?
Ma'am, it is not.
Go and correct it.
That's not it.
Go and correct it.
I think the balancing is wrong. Right. I think the balancing is wrong. Like it is not balanced.
I asked you whether it is right or wrong. You said it's wrong. If it is wrong, correct it. Whether you have to balance it, whether you have to take out one product, whether you add 10 products, do what you want to do, correct it.
So can I?
Please give her the chance.
It's a very small error. Sorry.
Give me.
It's just a 2 year. Yeah. Correct, right?
Now you balance it.
26.
Oh, sorry.
Is equal to or less than.
How much
Is
balance?
equal to or less than.
Correct.
Sorry. Sorry.
Equal to or less than.
You say sorry to yourself. You made an ass of yourself. I was just looking at what you already did it, and then you went on to something so complicated.
I didn't count the O.
The O was there. Okay.
I just said did something.
What is the definition of a chemical bond? What is the definition of a chemical bond? The bond. Yeah.
Chemical bond is a force that holds the atoms of two elements
What force?
together.
Force of attraction between two atoms of a compound to make a particular compound. Okay, fine.
That's the overhead. I simply want to study.
See, another thing in a chemical change and a chemical reaction. In a chemical change, only a single thing can change. But in a chemical reaction, chemical bonds are formed. Which is not there in a chemical change. Hello?
Yes.
I'll test a couple of things.
Yes.
Do you want this?
Then buy something for you. Like that's it.
I don't want to ask मेरी
आपने जाने नहीं बोला बस पैक अप कर दो
वो तो मेरी पहली
Chalo.
Yes. End soon.
What shall we do tomorrow? Tomorrow bring treasure
But not
chest.
Julius Caesar.
No, treasure
Julius
chest.
Caesar.
Tomorrow treasure chest we'll do. The last one is homecoming. That's one lesson we have to
I'm
complete.
really stressed.
Huh?
I read it's really stressed.
You learn?
I read that lesson, it's really stressed.
Really?
It's stressful.
Now,
Really stressful.
कुछ अच्छा है नहीं हमारी स्कूटी हम मुझे की
Oliver अच्छा है, but ये homecoming तो बहुत ही
मर जाता है
हाँ लास्ट में मर जाता है वो एक लड़का अरे टीनेज लड़का रहता है एक लड़का है ना वो टीनेजर बहुत मस्ती करता है तो फिर उसने उसको घर से बाहर निकाल
अरे नहीं
हाँ मेरे के पास इस अंकल के पास
एक बता
मैं पढ़ूंगी तब
बेटा को स्पॉइलर मत दे
हाँ